You are welcome to this fresh topic in Jamb syllabus. Remember, all my lectures are concise, straight to the point. We left no stones unturned in the Jamb 2026 syllabus. All right. So if you need any of my lesson notes, very short, concise, straight to the point, good and perfect for late minute preparation. I also have a plan, last minute plan, the sharp plan for Jamb UTME preparation. If you have not been preparing, or you are afraid that you are going to fail, or your reading or your study is not enough, come to me. Let me help you now. Because after this Jamb exam, I can't help you again, except until after another 1 year again. So grab this opportunity. So get your pen and your paper to jot down whatever you understand in this lecture as we progress. All right. So today we are looking at sulfur and its compound as specified or suggested by Jamb in her syllabus. All right. We are looking at the allotropes of sulfur first of all. The compounds of sulfur. Before you look at the compounds of sulfur, you are going to look at the allotropes of sulfur. Let me ask you a question. Sulfur belongs to what group in the periodic table? What group does sulfur belong to? Drop it in the comment section. We have treated periodic table, right? Sulfur, they which group? Oh. Let me teach you how to know the group, okay? If you don't know the group of sulfur, okay, this is what you are going to do. Provided you know the atomic number of sulfur, draw the orbital diagram and find the valence electron. That's the amount of electron in the outermost shell. That's the valence electron. The amount of electron in the outermost shell is is sulfur group. All right, so do that right away. Remember, when you are drawing orbital diagram, first spectra or first shell is 2 electrons. Second shell is 8 electrons. Third shell, and so on and so forth. All right, so that's the KLMNO shells. All right, so the allotropes of sulfur. The first allotrope of sulfur is the rhombic sulfur. Take note to the rhombic sulfur, and the rhombic sulfur is stable. Is the most stable allotrope of sulfur at room temperature. All right, is the most stable at room temperature. It has a yellow crystals, okay, yellow crystals, and it's used in matches and fireworks. Okay, so this sulfur you are seeing here is also called the red sulfur. It's used in matches. Dynamic matches, the red. Okay, take the striker, and then they use them for fireworks. If you look banger, where you shoot. If you look at me, you see one day reddish one kind, reddish brown one kind. So it is made with rhombic sulfur. The second allotrope of sulfur we have here is the monoclinic sulfur. Okay, the monoclinic sulfur. Okay, and the monoclinic sulfur is stable at higher temperature. It is what? Stable at higher temperature. The rhombic sulfur is stable at room temperature, while the monoclinic sulfur is stable at higher temperature. Even though you increase the temperature very high, monoclinic sulfur is still stable. And how does it look? It is needle-shaped crystals. Okay, it's needle-shaped crystals. In the textbook, when you look at your textbook, when they hit monoclinic sulfur, you are going to see the needle-shaped crystals that form in the beaker. You have like saying that needle. Then the inside the beaker is monoclinic sulfur. All right. The third is plastic sulfur, and this plastic sulfur is dark, rubbery. It is stretched like rubber. Okay, you have like say you burn rubber. Okay, come the pourer for something. If you look at your textbook, you are going to see it. It's dark, rubbery, and it's formed by rapid cooling of molten sulfur. When you cool molten sulfur rapidly, I already taught you the meaning of what molten is. Molten is when you place a substance in a semi-solid state. Okay, semi-solid state. It's not a liquid state. It's not a solid state. It's in a gel state. All right, it's in a gel state. All right, so that's molten. All right, so when you rapidly cool molten sulfur, you cool it very fast, you get plastic sulfur. All right, the allotropes of sulfur include rhombic sulfur, monoclinic sulfur, and plastic sulfur. Sulfur 4 oxide, the most common oxide of sulfur is sulfur 4 oxide. All right, and sulfur 4 oxide is prepared by burning sulfur in air or roasting sulfide ores. Okay, when you roast sulfide ores or you burn sulfur in air, sulfur 4 oxide is formed. That's the way of what producing sulfur 4 oxide or manufacturing sulfur 4 oxide. Okay, then the properties of sulfur 4 oxide include it's colorless, it has a shocking smell, and it's acidic oxide. Okay, it is what? Acidic oxide. Okay, why is it acidic oxide? Because it forms acid when it dissolves in water, and such a substance can also be called what? Acid anhydride. All right, so sulfur 4 oxide is the #1 cause of acid rain, because when it's present in the atmosphere, when the rain falls, sulfur 4 oxide, because it's an acid oxide, it's an acid anhydride, and it dissolves in water and forms what? An aqueous acidic solution of tetraoxosulfite 6 acid. All right, so that's why when it falls on you, it's already an acid. That rainwater that is falling is already an acid. When it falls on your skin, it corrodes your skin. All right, so it is the #1 cause of acid rain. Another cause of acid rain is nitrogen 4 oxide. Nitrogen 4 oxide. Okay, nitrogen 4 oxide is also another cause of acid rain, because when it's present in the atmosphere, because it's an acid anhydride, because it's an acid oxide, it dissolves in the raindrops and it forms what? An aqueous solution of triazonitrate 5 acid. And when that solution of triazonitrate 5 acid falls on your body as rain, it burns your body. That's already acid. All right, now let's look at the chemical reaction of sulfur 4 oxide. You know that under the physical reaction of sulfur 4 oxide is colorless. It has a shocking, it makes you shook. Okay, when you perceive it. That's why when you strike matches like this, sulfur 4 oxide is giving off. When you inhale that matches smoke, it's always pungent. you they do like this. that year the smoke matches smoke. If you like matches, we'll put that inside my life. If you don't do it, if you inhale them into your lungs, it will make you shook. Okay, so that's the property of sulfur 4 oxide. It's an acidic oxide, physical properties. Okay, now the chemical properties, the reactions. Sulfur 4 oxide reacts with alkalis to form sulfides and triazosulfate 4 acid. This is an unstable acid. This triazosulfate 4 acid is an unstable acid. So sulfur oxide reacts with alkali such as sodium hydroxide to form sulfides or triazosulfate 4 acid. And most of the time, this triazosulfate 4 acid is later converted to tetraazosulfate 6 acid as a reducing agent. Sulfur 4 oxide is a reducing agent and it's a bleaching agent too. It bleaches by reduction, unlike chlorine that bleaches by oxidation. I already talked about the advantages and the limitations or the disadvantages of using oxidizing agent or reducing agent as a bleaching agent. Okay, I said that if you use oxidizing agent is more powerful, it bleaches better, but it harms the fabric. What you are using it to bleach, the material. With time, the material gets bad. For reduction, bleaching agents like sulfur 4 oxide, it does not bleach so well. Okay, because when you expose the material bleached by sulfur 4 oxide to the atmosphere, with time, it is oxidized and you see that color, that former color when you bleach come out before. You will see the material will start gaining that color back again. So the bleaching is not that efficient, okay, but it's not harsh on the material. It's gentle to the material, so the material will last longer as compared to using oxidizing agents such as chlorine. Okay, so now let's look at the uses of sulfur 4 oxide. It is used as a bleaching agent. It is used as food preservative. It's used to manufacture tetraazosulfate 6 acid, and it is used to make matches, fireworks, all those things where they explode, and so on and so forth. It's also used to make hair cream. Okay, it's good for the skin. It is used to treat various skin conditions. Okay, sulfur. That's why you have one famous hair cream those days called Sulfur 8. Okay, it's used to treat dandruff and so on and so forth. Triazosulfate 4 acid, which is this triazosulfate 4 acid and salts. Triazosulfate 4 acid and salts. How is triazosulfate 4 acid formed? It is formed when sulfur 4 oxide dissolves in water. When you dissolve sulfur 4 oxide in water, it first of all forms triazosulfate 4 acid. This particular acid you see here. Okay, it is this acid that forms oleum. Then oleum is reduced towards tetraazosulfate 6 acid. So the salts formed by triazosulfate 4 acid is sulfides. Okay, what is the effect of the triazosulfate 4 acid? It releases sulfur 4 oxide to the atmosphere. And you know that sulfur 4 oxide is dangerous, very dangerous, because it causes acid rain. Alright, it's an acid anhydride, it's an acid oxide. It can easily cause what? Acid rain, which is very detrimental to human health. Alright, now let's look at tetraazosulfate 6 acid. Alright, tetraazosulfate 6 acid is prepared through an industrial process called contact process. And through this process, sulfur 4 oxide is dissolved in water and it forms what? Sulfur 6 oxide. Immediately sulfur 6 oxide is formed, triazosulfate 4 is also formed. And it's this triazosulfate 4 that now forms something called oleum. Okay, oleum. Okay, so this oleum, please search oleum on Google and find out the elements that is found in that oleum. I think oleum contains about 4 elements in it. Okay, that forms oleum. Either 3-4 elements that forms that oleum. Okay, it's a complex compound. Okay, so look for oleum. Okay, look for oleum and look for its constituents. Jamb sets that kind of question. They will ask you that the oleum formed during the contact process, what does it contain? They will put option. If you don't know them, you know Sabian. Now so you reach. At least see them with your eyes, so that if you see them among options, for example, you will remember. You don't need to put them for inside head, but see them. Take a glance, okay? Be familiar with it, all right? Get yourself accustomed to it, all right? So that oleum is what is reduced further to form tetraazosulfate 6 acid. It is through that oleum that tetraazosulfate 6 acid is formed. And we all treated the catalyst used in various industrial processes. Now, I want to ask you, what catalyst is used during the contact process? What catalyst is used? Drop it in the comment section, all right? So the properties of tetraazosulfate 6 acid include, it is a strong acid. Acid is one of the strongest acids on earth. So the concentrated form of tetraazosulfate 6 acid acts as an oxidizing agent. It's also used as a drying agent. Remember, tetraazosulfate 6 is hygroscopic, so it's used as drying agent. You know the meaning of hygroscopy, right? All right, when they become sticky, okay? They absorb moisture, the substance that absorb moisture from the atmosphere and become sticky. They don't turn to a solution. They don't dissolve in the moisture or in the fluid they absorb. All right. So what are the uses of tetraazosulfate 6 acid? It is used as fertilizers, or it is used to manufacture fertilizers. It is used to manufacture detergents. It is used in petroleum refining. It is also used as a drying agent because it's hygroscopic. All right. Let's see the test for tetraazosulfate 6 ion next. All right. The test for tetraazosulfate 6 ion. How do we figure out the presence of tetraazosulfate 6 ion? This is done for tetraazosulfate 6 ion. Is done by adding barium chloride. And immediately you add barium chloride to the solution in question, you are going to get a white precipitate which is insoluble in hydrochloric acid. All right, as simple as that. So add barium chloride to the solution, okay, to test for tetraazosulfate 6 ion. Add barium chloride to the solution, it turns white, and this white precipitate is insoluble in hydrochloric acid. So to test for triazosulfate 4 ion, you are going to add acid. Add any acid, okay? Add any acid to the solution. if sulfur 4 oxide is given off as a gas, just know that that confirms the presence of triisosulfate 4 ion. Remember the smell of sulfur 4 oxide, a shuky smell. All right. So what is the test for sulfur 4 oxide? Sulfur 4 oxide turns acidified potassium tetraoxomanganate 7 from purple to colorless. And what does that signify? It signifies that potassium tetraoxomanganate 7 has oxidized sulfur 4 oxide. Okay, it oxidized sulfur 4 oxide, and sulfur 4 oxide has reduced potassium heptaoxomanganate 7. Okay, that's why it's moved from purple to what? Colorless. All right, remember sulfur 4 oxide is a reducing agent. All right, so the test for sulfur ion. What is the test for sulfur ion? Sulfur ion is tested by adding lead 2 ion, any of the lead 2 ion. Immediately you add lead 2 ion to a solution containing sulfur ion, you are going to get a black precipitate of lead sulfide. A black precipitate of what? Lead sulfide. Okay, so what is the test of hydrogen sulfide? Remember, hydrogen sulfide is that sulfide or that compound of sulfur that smells like rotten egg. It's a gas at room temperature and it forms metal sulfide. Okay, so when you react it with metal, this hydrogen is displaced and you get the metallic sulfide. For example, you have sodium sulfide. Okay, and so on and so forth. Now let's look at hydrogen sulfide separately. Okay, hydrogen sulfide. What is the method of preparing hydrogen sulfide? It is prepared by the action of dilute hydrochloric acid on iron sulfide. The action of what? Dilute hydrochloric acid on iron sulfide. What happens during this reaction? This hydrogen here is displaced by this ion and we get hydrogen sulfide gas. And so we are now going to be left with iron chloride and hydrogen sulfide. All right. So what are the properties of hydrogen sulfide? It forms a weak acidic solution. It is a reducing agent. It forms precipitates with metal. That's the sulfide. For example, when you react a metallic compound or a metal itself to hydrogen sulfide, you are going to get the sulfide of that metal. For example, you react iron with hydrogen sulfide, you are going to get iron sulfide. All right, so that's that for that. What are the uses of hydrogen sulfide? It is used for qualitative analysis of metal ion. That's testing the qualities of metal ion. It's like test for metallic ion, the presence of metallic ion. Okay, because it readily forms sulfide with metal. That's why it is used for qualitative analysis of metal ion. Now let's move to nitrogen and its compounds. Okay, nitrogen and its compound. What's the laboratory preparation of nitrogen? Okay, nitrogen is prepared by heating ammonium nitrate. Remember, ammonium nitrate is a very unstable salt. So when you heat ammonium nitrate, it decomposes to form what? To form nitrogen and water. It's what? It decomposes, releasing its components to form what? Nitrogen gas and water. What is the industrial preparation of nitrogen gas? Very easy. Fractional distillation of liquid air. Remember, nitrogen is present in air at a very high ratio. About 78% of the air is made up of nitrogen gas. So when you fractionally distill liquid air, you first of all liquefy the air, then you fractionally distill it according to the boiling point of each of the gases. Then you separate nitrogen. All right. So what are the properties? The properties of nitrogen. Okay, nitrogen gas are inert. That's they don't react. Okay, they are inert, they are stable. All right, they are used to produce inert atmosphere. All right, they are inert, they are used to produce inert atmosphere, an atmosphere where you want no reaction to occur. In an atmosphere where inertness is highly needed, highly required, okay, you use nitrogen gas. All right, let's look at ammonia. NH3. Remember, NH3 is ammonia. NH4 is what? Ammonium. All right, what is the laboratory preparation of ammonia? It is prepared by heating ammonium salt with alkali. Heating what? Ammonium salt with alkali. When you heat any ammonium salt with alkali, you get what? You get ammonia gas. Ammonia gas is released. All right. For example, you heat ammonium chloride with alkali, sodium hydroxide. You are going to get what? Ammonia gas and what? Sodium chloride. All right. So what is the industrial preparation or the industrial manufacturing process of ammonia? It is manufactured through a process called the Haber process. In the Haber process, 1 mole of hydrogen reacts with 3 moles of hydrogen to form what? 2 moles of ammonia. This is a reversible reaction. And iron is used as a catalyst. Remember, we have treated all the industrial process and the catalyst use. Do well to find the lesson video and take it because Jamb always repeats questions from these. All right. So what are the properties of ammonia? What are its properties? What property does it have? All right. Both the physical properties and the chemical property of ammonia. Ammonia is an alkaline gas. Ammonia is an alkaline gas. Ammonia can react with acid to form salt. Yes, ammonia is a reducing agent. Okay. It forms salt. Okay. When it reacts with what? With acid, it forms salt because it's an alkaline gas. Okay. What are the uses of ammonia? Ammonia is used as fertilizer. Remember, ammonia is a nitrogenous compound. Thus, most nitrogenous compounds are used as fertilizers. All right. So ammonia is also used as cleansing agent. Used in cleaning. All right. It's also used to manufacture explosives. Remember, nitrogen is used to manufacture explosives. All right. Nitrogen is used to do what? To manufacture explosives. So a compound of nitrogen is most likely going to be used to manufacture explosives. All right. To test for ammonium ion, add sodium hydroxide to the solution. When you add sodium hydroxide to the solution, what happens? Ammonia gas is released. And as soon as ammonia gas is released, how do you know that it's ammonia gas? The smell. Okay, it turns moist red litmus paper blue because it's an alkaline gas. To test for ammonia, the presence of ammonia gas, you are going to see white fumes when you add hydrochloric acid to the solution. Okay, you are going to see what? White fumes when you add hydrochloric acid to the solution. Let's look at the oxides of nitrogen. The oxides of nitrogen include the nitrogen 1 oxide. This one is nitrogen 1 oxide. Nitrogen 1 oxide, which is also called the laughing gas. It is a neutral oxide. Okay, look at another one again, nitrogen 2 oxide. Okay, nitrogen 2 oxide is a what? A colorless gas. Is also a neutral oxide that oxidizes to form what? Nitrogen 4 oxide. So the third one is what? Nitrogen 4 oxide, which is a brown acidic oxide that is toxic. Okay, it also forms what? Acid rain when present in the atmosphere. All right, so that's that for the oxides of nitrogen. This is the nutshell of the nitrogen cycle. Okay, during the nitrogen cycle, different processes occur in the nitrogen cycle. I simplified everything and brought everything to you in a platter of gold. Let's look at each of them one after the other. It has what? 5 stages. Okay, 5 stages of what? Of the nitrogen cycle. The first process in the nitrogen cycle is fissation. And what happens during fissation? Fissation means join. Two things come together. Integration. They fuse, join. That's fissation. During fissation process, atmospheric nitrogen, the nitrogen found in the atmosphere, forms ammonia and nitrates. And this is facilitated by bacteria or lightning, thunder, bolts. That's what facilitates this process. Either bacteria or thunder. And the bacteria that turns nitrogen to ammonia and nitrates are called what? Nitrosomonas. Okay? Nitrosomonas. Okay? Then after the fissation process, assimilation process occurs. Okay? And during this assimilation process, what happens? Plants now absorb those nitrates through their roots. Okay? They use their roots to absorb those nitrates. And they use it for their what? Development. Okay, they use it for their demand. All right. So after the assimilation, plants absorb all the nitrates. What happens next? Ammonification, whereby organic nitrogen turns to ammonia. Organic what? Nitrogen turns to ammonia. This ammonification occurs where? In a living system. The plant does this ammonification. Okay, ammonification. After the ammonification, what happens? Nitrification. Okay, and what is nitrification? That ammonia that is formed during ammonification is converted to what? Nitrogen 4 ion. Okay, it's converted to nitrogen 4 ion. And then converted further to nitrogen ion. All right. So this nitrogen now takes us to the final stage of the nitrogen cycle, which is denitrification, whereby this nitrogen ion is converted to nitrogen back again, and it returns to the what? To the atmosphere. So it continues this way. That's why it's called cycle, nitrogen cycle. It continues this way. You can see that nitrogen has been gotten back again. So this nitrogen, the atmosphere, fissation will now occur again. This nitrogen will now turn back to what? To ammonia and nitrate by the bacteria or lightning. And assimilation occur, ammonification occur, nitrification occur, denitrification occur, and it turns back to what? Nitrogen back. Then it starts again, fissation. Just like that. That's how it's going to continue going. So nitrification is oxidation. Okay? Oxidation. That's nitrification. Ammonia is oxidized during nitrification. Then during denitrification, nitrogen 6 ion is reduced to nitrogen gas and it returns to the atmosphere to start up the cycle again. And so it continue. And so we take the live our life. The nitrogen cycle no dey stop. Alright? So what are the relevance? The relevance of the nitrogen cycle. Number 1 is to maintain soil fertility. Remember, plants uses nitrates, okay, for their demands, okay, their daily demand. Also, nitrogen gas balances our ecosystem. Nitrogen gas does what? It balances our ecosystem. Remember, nitrogen makes up about 78% of the air, okay? So that's that for that. Now that we have understood various cycles, oxygen cycle, nitrogen cycle, water treatment, and so on and so forth, let's now test how well we understood this topic and also measure our readiness for Jamb UTME 2026. Jamb must repeat questions. Question 246. Which allotrope of sulfur is stable at room temperature? A. Monoclinic sulfur. B. Plastic sulfur. C. Rhombic sulfur. D. Colloidal sulfur. What's the answer? I just taught you now. Drop the answer in the comment section. Don't disappoint me. Question 247. Which gas turns acidified potassium tetraisomanganate 7 solution from purple to colorless? A. Sulfur 4 oxide. B. Hydrogen sulfide. C. Ammonia. D. Nitrogen 4 oxide. What's the answer? Drop the answer in the comment section. I already taught you now. Please don't disappoint me. Question 248. Which salt gives a white precipitate with barium chloride that is insoluble in dilute hydrochloric acid? A. Sulfite ion. B. Sulfate ion. C. Carbonate ion. D. Nitrate ion. What's the answer? I taught you now. I just taught you. Please don't disappoint me. Drop the answer in the comment section. Question 249. The commercial preparation of tetrasulfate 6 acid is by what process? A. Haber process. B. Contact process. C. Solvay process. D. Ostwald process. What's the answer? I just taught you now. Don't disappoint me. Please drop the answer in the comment section. Question 250. Which gas has a characteristic rotting egg smell? A. Sulfur 4 oxide. B. Hydrogen sulfide. C. Ammonia. D. Nitrogen 4 oxide. What's the answer? Drop the answer in the comment section, my scholar. I just taught you now. Please, don't disappoint me. Question 251. Which industrial process is used for the preparation of ammonia? A. Contact process. B. Haber process. C. Solvay process. D. Ostwald process. What's the answer? Drop the answer in the comment section, my scholar. I know you know the answer. Question 252. Which test confirms the presence of ammonium ions? A. Addition of sodium hydroxide, which gives ammonia, turns moist red litmus paper blue. B. Addition of hydrochloric acid, which yields white fumes. C. Addition of barium chloride solution which gives white precipitate. D. Addition of iron 2 tetrasulfate 6 which forms a brown ring. What's the answer? Drop the answer in the comment section. Please don't disappoint me. I taught you this topic. I just taught you. Please don't disappoint me. Question 253. Which acid is prepared in the laboratory by heating sodium triazonitrate 5 with concentrated tetrasulfate 6 acid? A. Tetrasulfate 6. B. Triazonitrate 5. C. Triazosulfate 4. D. Hydrochloric acid. What's the answer? Drop the answer in the comment section, my scholar. Question 254. Which oxide of nitrogen is brown, acidic, and toxic? A. Nitrogen 1 oxide. B. Nitrogen 2 oxide. C. Nitrogen 4 oxide. D. Nitrogen. What's the answer? Drop the answer in the comment section, my scholar. Question 255. Don't disappoint me in this one, though. I just taught you. Which step in the nitrogen cycle converts ammonia to what? Nitrates? A. Denitrification. B. Nitrification. C. Ammonification. D. Assimilation. What's the answer? Drop the answer in the comment section, my scholar. Are you a late minute preparation JAMB candidate? Why not allow me help you to pass this JAMB? Do not sit at home again for another 1 year doing home chores. Come to my DM. Let me send you this short, concise, and straight to the point notes for your preparation. Very short. Just imagine that whole chemistry syllabus was compressed into 350 small slides. Just this small slide you are seeing here. Very sweet to read. As you read that, they enter your head. I also have a sharp plan that works for 9-minute candidates. Last minute preparation. Name them. I have materials that is going to help you. Even though say 3 weeks you get left to prepare for the exam, or 4 weeks or 2 weeks safe. If I can do it within 72 hours, I can still do it within 3 weeks, 4 weeks, 2 weeks. So what are you waiting for? Enter my DM and get these materials. The sharp plan to blast JAMB UTM in 2026 and also simplified lesson notes straight to the point.